Welcome class 9. In this video we'll be learning about simple electric circuit. So here we have a very simple circuit. Over here you can see there is a cell. Okay. Yesterday we have learned about the symbols that will be used. So this is a symbol of a cell. Here we have a switch and here is the load or simply bulb. Load means any appliance which will use the electric energy to do some work. So the bulb is using the electric energy to do some work. Alright, so a cell is signified or symbolized by uh, two lines. One is the longer one and the other one is shorter. The longer one represents the positive terminal and the shorter one represents a negative terminal. Okay, and here the switch is applied over here, but this figure has a mistake. Actually the switch is supposed to be out here in the positive terminal. All right, but the switch has been kept in the negative terminal. That's the mistake with this figure, with this connection. All right, so the switch is supposed to be out here. So when the current passes from the positive terminal, okay, over here this way, it reaches the bulb and it returns back and comes to the negative terminal. All right, if the switch had been over here, then making the switch off, then the connection would be, the connection would be open and there would be no current which would pass through the circuit. And when the switch is closed, that is the circuit is connected, then the current would pass through and the bulb would glow and it will return back to the negative terminal of the battery or the cell. So this is a simple electric circuit. All right, so let's consider that when the switch is kept on, the circuit is complete. Okay, and the current flows from the positive terminal, does some work out here, that is the bulb will glow. Okay, and the current will return back, okay, after dropping its work over here, after dropping its electric energy in the bulb, and it will return back to the cell. Okay, so this completes the circuit and hence the bulb will glow. Okay, and if the switch is kept off, no current would flow and no work would be done, that is the bulb would not glow, and hence the circuit would be incomplete. Okay, so this is a complete circuit where the bulb glows. Here we can see there are some electric components used in order to make this circuit complete. All right, so here we can see an ammeter is there, a cell, okay, the source of the current, key. Over here a key is used, okay, instead of switch. You can apply the switch also. Then there is a rheostat with the variable resistance. Then the load is there, that is the bulb, and again it returns back to the ammeter. So the cell, the longer line represents the positive terminal and the shorter one represents a negative terminal. Okay, so from here the current will flow if the key is kept closed. If the key is open, then no current would flow. Okay, and if the key is closed, that means the circuit is connected, then the current will flow here through the rheostat, that is from the variable resistance, and then it would flow this way. Then it would come to the bulb would glow, that is the work will be done, and it will return back. It enters the ammeter since it is the positive terminal over here. So the positive side enters first as a to the positive terminal of the ammeter, and here it is negative and it comes to the negative terminal of the cell. So this is how the connection is made. Over here you can see the switch or key is connected in series. This is called series connection. Then it enters the rheostat, which is again connected in series. Then the bulb comes, okay, and over here the ammeter is connected in series again, and over here the battery is there, okay, battery or cell. So for the load where the main work is being done, over here load is connected with the positive terminal in one side and the negative terminal in the other side. So this is the negative terminal of the cell from here to here, and the positive terminal from here to here of the bulb. Okay, and when this circuit is connected, the bulb will glow when the current will pass through all these components. Okay, and the work would be done. So over here the ammeter will show a reading, how much amount of current is flowing through. Okay, if the key is kept on. If the key is kept off, then no current would flow, so ammeter will not show any reading, the bulb will not glow. Alright, but when the key is kept on, okay, the current will start flowing, the bulb will glow, and ammeter will start showing the reading of how much current is flowing through the circuit. And suppose over here in this terminal, in the negative and the positive terminal, if a voltmeter is connected, okay, if a voltmeter is connected, then what will happen? If the voltmeter is connected, then voltmeter over here, the positive terminal is connected out here, and the negative terminal goes that way. Okay, meets the negative terminal of the cell. So over here the voltmeter is connected in parallel, and it shows the voltage across the terminal of the cell, or we can say the voltage across the terminal of the bulb. Okay, so over here the voltmeter shows what is the potential difference across the two terminals of a cell. So again, when the key is kept off, there will be no reading in the voltmeter as well, because there is no current which is flowing through the circuit, so voltmeter also would show the reading as 0. Okay, so this is how it works. Now suppose if you vary the resistance, if you increase or decrease the resistance, what will happen? Suppose first you keep this resistance fixed and you start observing the reading, then you will get a set of readings, a set of observation for voltmeter and the ammeter. Alright, now when the resistance is decreased, okay, if you decrease the resistance, then what will happen? If the resistance is decreased, then the current will increase, because resistance decrease means the current has to increase, and when there is more current flowing through the circuit, then the bulb will start glowing more brightly. Okay, and with more brightness, we will know, with more flow of current, we will know that ammeter reading will increase, and since there is more current flowing through, so the voltmeter also will show its reading getting increased. So ammeter and voltmeter, both the reading will increase. And suppose if you decrease the resistance, if you increase the resistance, okay, if the resistance is increased, then the current which is flowing through will get decreased, then the brightness of the bulb will go down. That means the brightness will decrease, okay, because the current has been decreased. So the ammeter reading and voltmeter reading will also decrease. Okay, so this is the relation that you need to understand in a simple electric circuit like this. Okay, resistance decreases, current increases, the bulb will glow brightly, so ammeter and voltmeter reading will show the increase. And when the resistance is increased, the current will decrease, okay, and the bulb will glow less brightly, means the brightness will go down, and the ammeter and the voltmeter reading will also go down, means its reading will show the decrease of the values. Okay, so this is all about simple electric circuit. Thank you.